Okay, I'm back right from the left video. So what we're going to do now is going to make this character moves with animation. So first thing we are going to do, we're going to create a new C++ class on public core characters. We're going to create a new C++ class. The type, we're going to click here, show all classes. We're going to look for anim instance. This one right here. I'm going to click next. We're going to name anim inst, a simple name. Gonna put it on the folder characters animations. So we have separated folder, and we create class. Okay, give me the same thing every time. So what I'm going to do now, I'm gonna stay on the editor. We're going to go to the folder assets. We're going to create our blend space. So assets, animations, mobility, and animations. We're gonna create a folder here. We're gonna call it blend spaces, and we're gonna create a new blend space. So animation blend space. Going to be that skeleton. It's going to be BS movement stand, just movement. Double click it. We're gonna move our animations to here. I'm gonna increase this. Gonna put here walk. I'm gonna drag the IPC, so walk EIPC. It stands for in place. So the first one I'm gonna put here is walk forward. We actually not gonna put now. We're going to skeleton tree, add set details. We're going to horizontal. We put direction -600 and 600, and the number of grid divisions will be 8, and interpolation time will be 0.25. So this gives a little blend between the animations. Same thing for speed, -600, 600, 8.25. We have this kind of grid here. Next thing we're going to do, the walk forward. We're going to drag to the direction 0, speed 150. So we have this. The next one, walk backward. So mob 1, walk B in place. It's going to be direction 0, speed -150. We have this animations here. Next thing, I'm going to use the walk backwards left. So mob 1 walk BLB loop IPC. So it's going to be direction -150 and speed -150. So we have this. Same thing to the right, but instead of the direction being negative, it's positive 150. It's going to be like this. Forward, we're going to put the forward left here, forward right here. We have this. We have here to mob 1 walk L IPC. This is what we want to hear. The speed 0 and directions -150. We have this. The right version is going to be the same. Instead of 150 positive, negative, it's going to be positive with 0 of speed. And for walk, this is it. Now we look for jog. So jog, I have backward loop, walk backwards. So this go to speed -300, and to the last here speed -600. But the second one in the speed -600, what we're gonna do in the rate scale, we're gonna up this for 1.75. So it's a little bit faster than this one. Walk us backward left, jog backward left. Going to be minus 300 on both direction and speed, and right is going to be positive 300 on direction and speed. And the same for speeds, it's going to be 600 600 600 600. Jog forward, we're going to use jog F loop. It's going to be on the speed 300 only. Forward left is going to be directions minus 300 and speed 300. The forward right is going to be 300 positive on both. And we have jog L, so to the left, going to be direction minus 300, and to the right going to be 300 on direction positive. So we have this. And I think we're going to look for run. We have run forward loop, so it's going to be 600. Forward left, so it's going to be 600 600, and forward right is going to be 200 negative on 100, and actually gonna create a copy vector and I'm gonna copy this here. So copy here. So I have a copy of this exactly same blade space. To the engine, not to the engine, to the Visual Studio. What we are going to do is we are going to open our game definitions. Open it if it's not open already, like I have here. What we are going to do, we're going to define some structures so we have more control over our animations and be more organized. So we're gonna create a structure. To do that, Unreal Engine we do ustruct blueprint type to expose this to the editor. I'm gonna type struct, the name of the struct that you want, with the prefix with an X, with an F. So it's F movement structure. We need to add generated body, otherwise it's not going to compile. Now what we're going to add here is the current velocity, the forward velocity, so it's view property, added defaults only, blueprint read right, category is gonna be movement, going to be the type float, movement for x axis, so it's the movement on the x axis. Let's put forward, it's better. Movement forward axis, movement value on the forward axis, use the control animations. The same thing is going to be the move right axis, movement right axis, movement right axis, and and we're gonna add a new one for the rotation of the camera, so it's the yaw. So blueprint read right, category movement, and the float. It's gonna be the type the float, the name with look up axis. There's gonna be this value by default. Everything by default is going to be 0, so we zero out this. Here is the lookup axis going to be defined by the pitch of the camera, of the controller. So pitch control for animations aim offsets use. The same thing but for the yaw, so it's going to be look right axis and it's gonna be yaw here. And the category instead of movement is going to be look and feel. And next thing we're going to add, it's a boolean. So you property add defaults only, blueprint read right, category look. No, it's going to be movement. Let's be a boolean, so bool b turn left equals false, and we're gonna create the same one basically, so but follow the right. So blueprint right, category movement, gonna be bool b turn right equals false. This is going to control the turn in place animation, so control turn in place animations, left and right. We are going to create a new structure, new struct, blueprint type. Struct is we're gonna name to f movement speed. We're gonna add generated bodies because we need to. You're gonna add a new variable, so it's added defaults only, read it right, category speed. We're gonna add a new variable, so float, going to be the type float, and going to the names is slow speed, going to be 500 and 150. We'll create a new one, new property, edit defaults only, right, category speed, float medium speed, so it's going to be 300, and another one for faster is fast speed. So this is basically going to be walking a speed, jogging a speed, and fast speed like sprinting. And running speed. Why we are using this? Because when the character is stand, like it's not crouched, it's going to use this default values. If it's crouched, you're going to use another. So we have this, we have more control of the values without having to create like 9 structures, 9 variables. So here I'm going to add this right now here, so you property add it defaults only, blueprint right, category, movement, going to be F, movement speed, going to be movement speed, the name of the variable to control the speed of the character, standing or crouched. And I'm going to create a new enum, so enum blueprint type, going to be enum class E, and going to be stance state, so be a uint8. So ESS stand, ESS crouch, ESS jump. This will allow us to control more. So here we're actually gonna make a T map of this variable, and the first value here is going to be the U stance state, and this is it. This will have all the velocities based on which stance is the character. Like if the character is standing, it's going to use the value for this. If the character is crouched, it's going to use this. If it's jumping, it's going to use another one, and so on and so forth. So what I'm going to do here is initialize this structure. So movement structure and movement speed. I'm gonna add new F movement speed, crouched speed, gonna be slow speed, it's gonna be 75, crouched speed, median speed is going to be 100, and crouched speed at fast speeds is gonna be like 155 or 150, it's better. And movement speed, we're gonna add a new one. The class gonna be is, why it's giving me an error here? Public. Oh, just forgot the uint8. So we'll do this for us. So we're gonna add an E stance state, and gonna be a ESS crouched. So when the character is crouch actually, and we're gonna add this structure, crouched speed, that's correct. And we're gonna add this to the structure. I'm gonna add a new one, speed not add, we're gonna give an error here, ESS crouch. That's correct. Same thing we're gonna do here, but instead for be crouching, we want this to the when the character is standing, so ESS stand, and we'll leave it as it is. So F movement speed structure, no, movement speed, and we do this movement speed dot, when it's the jumping, we do the same thing here. So F movement speed, as we don't need different velocities when jumping. So this is it. This will help us with what we want to do inside the base character class here. So as we have done this, we go back to the character class. We're gonna add the variable, so U property, edit defaults only, blueprint really right. The category gonna be movement, we're gonna add F movement structure, and we name it movement struct. This will have this will store the information about the movement of the character. We're gonna create a function, so U function virtual void. What we are going to do is, as we want to override this on a new character that we have, so U function virtual void update character animation structure struct, and we added parameters delta time type of float. Gonna be like this. It's gonna be called on event tick. The reason why I don't do this on the anim instance, it's because I can do this here, and anim instance is more like for something more complex, more simple actually. So I put the update character animation here. I call on the event tick and give it the parameter, so it's delta time. What I'm gonna do is here on update character anim struct, I need to have an reference to the anim instance of the character. So we're gonna open the anim instance, public core character animations anim inst. I'm gonna create like the same variable here, but on the game instance, the animation instance, and I only name it differently, anim inst. So we have access to this variable on the anim instance. We are going to create a class here on animations. We go back to the editor, create a new class, blueprint, not blueprint, animation blueprint. Let's select the skeleton, and it's not here yet. We have to compile so it shows. So just press Ctrl B and wait. I forgot to inherit the game anim instance here, so what I'm going to do is add here. So hashtag include core data VM game interface.h, and this will allow the compile. Okay, I forgot to fix the path here, so it's core characters animations /anim inst. Now build and wait. Okay, did finish compiling. Now if we go here, we can create here animation blueprint anim inst with the skeleton anim bp underscore movement base or base movement. Now we drag from here and type default because we want this slots. We create a new state machine, so create state machine, add new state machine, locomotion. We cache this, so it's locomotion cache, and we call it here locomotion cache. We comment here is as final result, and here we comment as base movement. Double click it, open it, add state idle. We want the idle here, so then relax here. As we have created the structure there, we can click here, show inherited variables. We drag from here, we get, we break here. Here we will select the animation. I forgot to do something there, but we'll do it in a second. First we just connect here, so we have an animation playing here. From idle we add a state, movement, connect back. Same thing, I will do something there later. Yes, movement. I got this, break. You can press Q to straighten the connections. Forward is speed, right is direction. Compile, save. Here I will do something later. What we are going to do now is we are going to copy a reference to this, find it, copy reference, and we're gonna set here to the character right at the beginning. So how we do that, we the same thing as here, static constructor helper, helpers, f object finder, u class, and character animation inst equals text, and we add it here, add double quotes, and we take this out. If character animist succeeded, we get mesh set anim instance class to our animation there, animation font dot object. Set default anim instance, set default mesh. We have this. Now go back to our definitions. We're going to create a new variable, so it's your property, add defaults only, blueprint read and write, category, movement, it's gonna be the type, E is this state, it's gonna be stance state, current stance. And we'll have this to work on the animation blueprint. Another one that we need to put here is add defaults only, blueprint read and write, category movement is B is moving. We need to check if our character is currently moving. And not on either state. And we'll add a new enum here, enum type, enum class E speed state, I speed state event, ESS2, so ESS walking, ESS jogging, ESS sprinting. We added here too. Now we go to our character here. What going to do on update character administract, we will castle our animation instance, so uninst equals cast uninst, going to be get mesh get anim instance. If uninst, we will return. We had our header here, custom classes, hashtag include core characters animations, and uninst.h to get rid of these errors here. And just drag this all the way there. Uninst movement struct uninst equals to movement struct from our character. So movement struct. Basically gonna make a copy of it with a few changes, like movement struct, the one in the character. It's going to be add movement forward axis, going to be a vector dot product actor forward vector. It's gonna be and velocity. You're gonna get the dot product of these values here. The same thing for the right one, movement right axis vector dot product get actor, but instead of forward vector we are going to get the right vector and get velocity. And this will be passed to the movement struct on the enemy instance. What can we do here too is define if the character is moving already. So if our get velocity dot size greater than 1 have movement struct that is moving equals to true, or false. If the character is the current velocity of the character is greater than 1, it means it's moving. If not, it's not moving. So just defeat this here. This will be used to this will be used for the turn in place animations and some other stuff. So it's moving. Another thing we are going to do, we are going to check if look right axis on the movement struct, look right axis is greater than .13. If it is, our movement struct dot be turn right is equal true, otherwise it's going to be false. Almost the same thing for turn left, but instead of being greater it's going to be less, and it's going to be, instead of positive dot 13, it's going to be a negative dot 13. And now we can compile. No, not really, not yet. We are going to our header file of our character. We're going to create some functions. Virtual void. Actually, you don't need to be virtual. So void input move forward. Your function void input move right. We have to add parameters, so it's value value, your function void input look up value, function void input look right value. I have this as some inputs. So what I'm gonna add here is a pragma to separate this region from another. So inputs. I like to do this to get more organized. So when I want, I just do this. Gonna make this go away. So I will declare all of this. Quick create definition and define actually. Implement. Close it, look up and look right, we'll do the same thing. We have here, we are going to make our character move forward. So if we do not have our controller, or the value is equal 0, we will return, because we don't want to continue. So what we'll do, we get the rotation. So it's const f rotator rotation equals get controller rotation. We add a new rotator, so it's going to be a yaw rotation. 0, rotation dot yaw 0. Have this, and now we get the forward axis. So it's const f vector direction equals f rotation matrix yaw rotation get unit axis. It's going to be on the x axis, basically forward. We can just copy this and paste it here, and instead of the x it's going to be the y axis. So here we can comment this, get right axis vector, and here we comment get forward axis vector. Input lookup, we'll do add controller pitch input, and we want to add this. And for the right you're gonna do the same thing, but instead of pitch we're gonna do yaw, so value. And here we are going to make our character move. How we do that? We do add movement input, and we do direction and the value. We can do the same thing down here. Let's copy and paste, we have it here. Now we're going to set our inputs here. So what we do is check if the player input component is valid. We have it here, and we'll bind all the actions to this character. So player input component bind axis, move forward. It's gonna be this, and a base character input move forward. Move backwards will be the same thing, only we'll change here the input here. We can copy and paste this. Move right, paste, we're gonna move right and move left. Add here to another play input component, bind axis lookup, this and this character input lookup, and we'll do the same thing here but to look right. Now if we hit Ctrl B, it will build for us, and I will be back in a minute. Okay, did finish compiling, so let's open it. It didn't find our anim class here, but it's not a big problem, as we gonna set manually. So here on the anim blueprint, open anim blueprint, movement struct. You can see here is a locomotion here. Drag this, click here, I'm gonna break it, and I'm gonna look for is moving, and we are going to connect here. Duplicate this, and same thing here. If it's not moving, then we will go back to idle state. Okay, now what we need to do is this break. Here we have it. Movement speed, movement stance, movement speed. I'll change this later. For now, it's just this. So we have it here. Need to reconnect this because of the route we load. Send this away. Here, compile. Everything's working fine. So I'll minimize this. Now open the player character, and I'm gonna set the animation instance here, as I did not do that on C++, so set here, and I'm gonna drag as already here. One thing that I want to do is on auto-possess player, I have to click there. I want to set to player 0 because right now we don't have a game mode. And now if we play, we can be moving, as you can see. But it's not moving like I want to. The S key for some reason does not work. Now let me check this real quick. Backward, S, forward. Okay, it's just an naming problem. If I do this, I'll be rotating. And one thing I can do here to make it look better, I'll do that in C++, so it will stay. One thing I want to do is be use control rotation to false. I will add some header here on the game definition so it's easier. Hashtag include game framework slash character movement component.h. I will add this. This will allow me to change some things. First thing that I want to change is the rotation of the character. So get character movement component, and what I'm going to do is be orient rotation to controller. I think is the right. I think I'll use this b use control rotation is equal to true, and get character movement. Actually, it's not get character move component. B or it's wrong here too. So B use controller desired rotation is equal to true, and here we are going to do orient rotation to movement equals false. This will give a more smooth transition between the rotations. So character movement, and we're gonna change the rotation rate. So rotation rate going to be theta 0, 180, and 0. I think I'll do 90. Another thing, get character movement for the next video is gonna be nav agent props dot beacon crouch equals true, and we're going to change the velocity. So get character, no, not right now. If we build this, I will be back after it builds. Okay, finish compiling, finish building. Let's check. Save it. I won't save it right now because keep it popping this annoying thing. I move. It'll try to move accordingly. If I move here, you do this. As you can see, I can change the velocity too. I'm gonna try to play this on a bigger screen, and that's when we're gonna use the turn animations to look more natural. It will rotate to match the rotation of the controller. can change the velocity so we won't be so fast. So I'm going here 300. So just jogging. So that's it for this video. The next video we'll be doing the turning place and crouch animations. So yeah, see you in the next video.